Good morning, dear students. My name is Ferhan Mazher, and today is 11th January 2021. Right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. This is Cambridge O Levels Physics, and today we have set our hearts to solve an alternative to practical. We call it paper 4, and today we have selected October-November 2017 4-1 paper. This paper belongs from the zone 1, and the time allowed to complete this paper is 1 hour. The marks this paper carries is 30 marks. So let's start this paper, and let's go to the question paper. So on your screen, the question paper is showing up, October-November 2017 4-1 paper, alternative to practical, 1 hour time is allowed. A student finds the mass of a table tennis ball using a top and balance as shown in the figure 1.1. The top and balance reads to the nearest gram. The mass of the ball is about 2.5 grams. Suggest a reason why placing the ball on the top and balance does not give an accurate value for the mass of the ball. It's a 1-mark question. You see, the ball, the tennis ball, when you put it on the top and balance, the ball will not become steady. It will always moving a little bit, and it will. So due to the motion of the ball, the reading on the top and balance will continuously be changing. So let me show you my answer. I have written this answer. So here we go. Ball do not remain steady on top pan. This alters the reading on the balance. That's the difficulty which you will be facing. So that was the question number 1, A part. Okay, so the next part. And it's a 3-mark question, okay? The student uses 10 identical balls and a glass beaker to hold them as shown in the figure 1.2. Explain in detail how the student can obtain a more accurate value for the mass of the one ball. So instead of measuring directly the mass of one ball, this technique can be used. We will take a beaker, we will put it on the top and balance. We will measure what's the mass of the empty beaker. We will call it M1. Then we will put the 10 tennis balls in that beaker and we will measure the mass of that beaker and we will call it M2. Then subtract M1 from M2. That will give you the mass of 10 tennis balls. Divide that mass with 10 because there are 10 balls. That will give you the mass, average mass of a one tennis ball, and that will be more accurate. I hope you understand. Let me show you my written answer. It's a 3-mark question. So let me show you my answer. Okay, put empty beaker on balance and note its mass M1. Put 10 balls in beaker and find mass M2. Mass of 10 balls will be M1 minus M2. I think I made a mistake here. This should be M2 minus M1. Let me correct this. This should be, it's a felt pen. So this number should here, it should be M2 minus M1. Okay. Divide M2 minus M1, M2 minus M1 by 10. It will give you mass of one ball. Okay, so hopefully you understand. We will keep it. Okay. So let's move to the next part. The next is question number 2. So that's it. That was the question number 1. And this is the marking scheme showing up. And whenever we are solving the paper of physics, I always tell you that checking your answers, comparing your answers with the marking scheme is very important. So now you can see that the question number 1, May, June 2017, 4-1 paper. The question number 1, its marking scheme is showing up on your screen. You can see It's the mark distribution of each part. You can compare my answers with this marking scheme, your answers with this marking scheme, your teacher's answers with this marking scheme. Even if you are reading from the red spot, compare the answers with this mark. It's a very important practice. Okay, so pause the video, take your time, read this marking scheme. I have already compared my answers with it. So let's go to the next question. So the next question coming up on your screen is question number 2. A student investigates how high a table tennis ball bounces. He drops the ball from a height of 60 centimeter onto a tilled floor. Sorry, I said tilled floor, it's tiled floor, as shown in the figure 2.1. He records the height h of the bounce using a meter rule with the millimeter divisions. So what they are going to do, here they have the tennis ball. For example, they take the tennis ball to a height of 100 centimeter. From there, they drop it. The ball will hit this tiled floor and the ball will bounce. And they are actually, so there are two heights involved. One height is the capital H, that is the height from where the ball is dropped. And the small h is the height which in the bounce the ball will attain. Hopefully you understand this story. This is figure 2.1. They say the ball is placed near the meter rule so that when released, it falls 60 centimeter before it hits the floor. On the figure 2.1, draw the ball in its starting position. So this is 60 centimeter. So draw a line here, and above this line, draw a ball here. I've done that. Let me show you. So here you can see 60 centimeter, and here I have drawn a ball. Hopefully you understand. Okay, so it was a 1 mark question. Before recording any values for the height of the bounce, the student performs a trial drop. Suggest a reason for doing this trial drop. So before actually dropping the ball and actually measuring it, he do a trial drop. So for example, he drops the ball from the 60 centimeter and he looks at how high it went. So what's the benefit of doing this is that when you have done this, you have an idea that how high the ball will go in the bounce. And so you can place the observer. So once you have an idea, for example, if I know that the ball will reach 40 centimeter in the bounce, so he will have an idea that the observer should be here to observe the height of the bounce. So let me show you. It's a 1 mark question, and let me show you my written answer. Here we go. He finds approximate location to position observer's eye to measure bounce, the height of the bounce, small h. Hopefully you understand. Okay. He drops the ball 5 times from 60 centimeter and records the following values of h: 40 centimeter, 39 centimeter, 40 centimeter, 42 centimeter, 40 centimeter. So there's a reason why h is recorded to the nearest centimeter. You see, you are measuring the height of the bounce, and there is a little distance between the ball bouncing and the scale. And this is one reason. The other reason is that the ball is moving very quickly. It's in the bounce, so it's moving quickly. And so it's difficult to measure very accurately the position of the ball at its highest point. So that's why you do not go beyond the centimeter. So that's why we have measured up to a centimeter. Hopefully you understand my point. Let me show you my written answer, and here we go. We cannot locate the position of the ball in motion more accurately than a centimeter. Okay, we cannot locate the position of the ball in motion accurately more than a centimeter. Okay, because there's some distance between the scale and the bouncing ball, and the ball is moving obviously, and it's moving quickly, so it's difficult to locate the position. So that's why we do not go beyond 1 centimeter. Okay, less than 1 centimeter accuracy? No, 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 no. More than, sorry, no, I don't use the word less than. More than 1 centimeter accurate? No. For example, you cannot answer in millimeters here. Calculate, the next part is calculate the average bounce height. Give your answer to the nearest centimeter. You want to find average. 1, 2, 3, 4, 5 observations. You add them up and you divide their sum with the 5 because there are 5 number of observations. So very simple. Let me show you my average value. I've done this. Okay. So here you see the average bounce height will be equals to, I have not written height here. Average bounce will be equals to 40 plus 39 plus 40 plus 42 plus 40. So whatever the answer, whatever the sum is, you divide equals to divided by 5, that will be 40.2. So and we have to give your answer to the nearest centimeter, 40.2, it will be 40 centimeter. So it's a 2-mark question. So let's go to the next part. Okay, then they say the student extends the investigation to find the average bounce height from other drop heights. Find figure 2.2 shows the results obtained. So he dropped the ball from 60 centimeter height, 100 centimeter height, 140 centimeter height, 180 centimeter height, 220 centimeter height, 260 centimeter height. He dropped the ball from these respective heights, and he notes what is the height of the bounce. And they have noted that in the table. So if on the figure 2.2, add your value of the H average at the height of 60 centimeter. So when he dropped the ball from the 60 centimeter, the height average of the bounce, we already have found that. We have to enter that value here. That was 40 centimeter. So let me show you. Okay, so on your screen, you can see I have entered that value 40 centimeter in that table. Okay, so okay, the second part, to get the larger values of H, the student changes his apparatus and method, suggest how he does this. So if you want to measure the heights which are more than 260 centimeter, so even more than 100 centimeter, you have to use a measuring tape instead of a rule, because the rule is maximum 100 centimeter long. So when the height from where the ball is being dropped is more than 100 centimeter, then you have to attach 2 rules or 3 rules, or you can use a measuring tape. And when you drop the ball from more than 100 centimeter height, I think it will be better to use 2 students. One will drop the ball for the bounce, and the other one will observe the bounce, the height of the bounce. So 2 students will be required, and you can use a measuring tape, or you can attach the multiple rules with each other, because each rule is a maximum 100 centimeter long. So if you're dropping ball from more than 100 centimeter height, then you need a measuring tape or multiple rules attached or taped together. So let me show you my answer. Okay, so here we go. If H value is larger than 100 centimeter, they need to use tape measure. They need more than 1 student to measure H and drop ball. Okay, so I hope you understand. Okay. On the figure 2.3, plot a graph of H average in centimeters on the y-axis against the H centimeter on the x-axis. Start your axis from 0, 0, draw a smooth curve of the best width. Okay, so the ball, the height of the ball from where you drop the ball, capital H, that should be represented on the x-axis, and the small h, which means, let me show you the table also. Yeah. Now, this value will be on the x-axis and these values will be on the y-axis. These values are from 60, maximum values to 60. Okay, these values maximum up to 96, almost 100. So we have to prepare a grid and then we have to draw a smooth curve. So these are the coordinates. Okay, so let me show you. So here we go. So this graph, question number 2, D sec third part, you can see here on the x-axis we have represented the capital H in centimeters, 50, 100, 150, 200, 250, 300, 350. Here H average, the height of the bounce, small h, and here 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Then I have plotted these points. You can see these red dots. These are the points. From where these points are coming? This table. It will be 60, 40, 100, 56, 140, 74, 180, 96, 220, 94, 260, 96. So I have plotted those points and then I have to try to draw a best curve, a smooth best curve. So in the best curve, we try to such that the number of points which are above the curve, they are below the curve, and the curve is smooth. So I think that I've tried to draw the best curve. Hopefully you can draw a better curve here. Okay, so here I have in the same smoothness, I have drawn this and 0, 0. I joined it with the smooth curve. Hopefully you understand. It's a 4-mark question. So let's go. Okay, now with this. Get done with this. Okay. The student does not take any readings of H average for H less than 60 centimeters. Suggests why these readings are difficult to take. Okay. You see, when you drop the ball from less than 60 centimeter height, the ball will bounce up to 20 centimeter or 10 centimeter or maybe 40 centimeter. If the ball is bouncing only 30 centimeter from the floor, to observe this really height, the student will have to lie down on the floor because the ball will bounce only 30 centimeter. So to observe it accurately, you have to lie down on the floor with your head on the floor, and then you will be able to do this. So that's why he's not dropping the ball from a height of less than 60 centimeter. Hopefully you understand my idea, because it's difficult to observe the bounce, and plus the ball will be moving very quickly, so it's difficult to note down. So let me show you yeah, this one. I will show you my answer. Okay, sir. So the bounce will be of very small height. To measure it, student has to lie down on the floor. I hope you understand my point. Then he says, use your graph to estimate the value of the H average when H is 40 centimeter. Okay. So when H is 40 centimeter, it's this from here, you go there, and 30. So if you drop the ball from 40 centimeter height, the bounce will be of 30 centimeter. So let me show you. Yeah, that's why I've written here 30 centimeter. Hopefully you understand. Okay. Now, let's check. We are done with this part. Okay, so the question number 2 is completed. The question number 2 is completed. So let's have a look at the marking scheme. Here we go. So the marking scheme of the question number 2 is showing up on the screen. You can pause the video and have a good look on the marking scheme. A part, B part, C part, and D part, and D part. And then we go. This is the D third part, E first part, E second part. Pause the video, take your time, look at this marking scheme carefully. check my answers, compare them with it, because I can also make mistakes and you can also make a mistake. Your teacher can make a mistake. Everybody can make a mistake. So it's better. It's always recommended that you check your answer. You compare your answers with the standard marking scheme issued by the Cambridge O level. So hopefully you understand this point, and let's move to the next question. Figure 3.1 shows a thermistor. A thermistor is a type of resistor whose resistance is affected by changes in temperature. So thermistor, I can tell you that thermistor is a resistor whose resistance depends upon the temperature. And normally what happens in our course, we are studying that kind of thermistors whose resistance, when the temperature rises, its resistance decreases. But when the temperature becomes less, it becomes cold, the resistance of the thermistor increases. That's the theory which we have studied in the book. So figure 3.2 shows a partially completed circuit. Okay. So the thermistor is connected between the A and B in the circuit on the figure 3.2. Draw the correct circuit symbol for the thermistor between A and B. So here we have a battery 5 volt. Here we have a resistor which is 1000 ohm. Here we have a voltmeter which is which is across the 1000 ohm resistor. And here we have to connect a thermistor. So here I have to draw the symbol for the thermistor. It's a 1 mark question. Let me show you my answer. We have to draw the symbol of the thermistor. So remember this, in our Desi language, we say we make a resistor and then we draw hockey here. We say it's a hockey, ice hockey, you know. This is the symbol for the thermistor. Hopefully you understand. Okay, so here we go. Question number it's question number 3, and it's B part. The voltmeter, the thermistor is at room temperature, and the reading on the voltmeter is shown in the figure 3.3. So the thermistor is at the room temperature. So the reading on the voltmeter is how much? This is 2.2, 2.4, 2.6, 2.8, 2.8 volt. B first part. So here you have to write 2.8 volt. I can increase the size so you can see it more clearly. So you can see 2.2, 2.4, 2.6, 2.8. So the reading is 2.8 volt. Okay, so you will write 2.8 volt. Okay, so the next question is, the student then records the reading on the voltmeter when the thermistor is at a steady temperature of 0 degrees centigrade. So now they want to note down what is the reading on the voltmeter when the thermistor has a temperature of 0 degrees centigrade. So just how she can reduce the temperature of a thermistor from room temperature to 0 degrees centigrade. The standard method of short chart in which you bring the temperature of a thing to 0 degrees centigrade is by putting that thing in melting ice. So what you will do, you will take a beaker. In that beaker, you will put melting ice. And we know that the melting ice temperature is 0 degrees centigrade. So we will immerse the thermistor in that melting ice, and then we will wait for some time, and then we can check the reading on the voltmeter. So put the thermistor in the melting ice. Let me show you. So this is the symbol for thermistor, and the reading is 2.8. She can take melting ice in a beaker and put thermistor in that beaker. Melting ice temperature is 0 degrees centigrade. So the thermistor will be subjected to the 0 degrees centigrade. Okay, so let's move to the next part. He says at 0 degrees centigrade, the reading V on the voltmeter is 1.8 volt. So when the temperature is 0 degree, the voltmeter's reading is 1.8 volt. The resistance R of the thermistor measured in ohms can be found using the formula. Here, this is given in the question. The formula for finding the resistance of the thermistor is R equals to 5000 divided by V minus 1000. So calculate the R at the room temperature and at the 0 degrees centigrade. Give both answers to two significant figures. So at room temperature, the R value, I can apply that. I can use that formula. At the room temperature, the V value was 2.8 volt. And at 0 degree centigrade, R value, at the 0 degree centigrade, the V value is 1.8 volt. So we'll use those numbers, we use the formula, and we can calculate the resistance. Okay, so let me show you. Hopefully you understand. Okay, now when it was room temperature, so I can use this formula, 5,000 divided by, at room temperature the V value was 2.8 minus 1,000. Just enter these values like this in the calculator. 5,000 divided 2.8 minus 1,000 equals to, and that will be 785.7 ohm. And because we have to give the answers in two significant figures, 7 and 8, so it will be 780. Or you can say 781. You can also, but we cannot write 1. So 780 I have written here. So at the ice, at the ice point, our 0 degree centigrade, the R will be 5,000 divided by 1.8, because the V value was 1.8 when you subjected the thermistor to the ice. So 5,000 divided by 1.8 minus 1,000 equals to, that will be 1777.8. So it will be approximately 1800 ohm. 1800 ohm. So this can be rounded off to 790 also. Okay, remember that. Okay, so let's check the next part. Use your results to state how the resistance of the thermistor changes with the temperature. Okay, so it's a 1 mark question. And after that, the next question will show up. Okay, let me show you my answers. Okay, so when the temperature is, you can see when the temperature is room temperature, the resistance is 780. But when it's ice 0 degree centigrade temperature, the resistance is 1800. So very easily I can tell you, we already know that when the temperature rises, the resistance decreases. At ice at 0 degree centigrade, at ice point at 0 degree centigrade, the thermistor's resistance is higher, it's 1800. But when the temperature is room temperature, the resistance rises, the resistance decreases. So we can write that answer. Okay, as temperature rises, the resistance of thermistor decreases. So that's it. That is question number 3. So let's have a look at the marking scheme. Here's the marking scheme. So it is 790. I told you to round it off to the 790. Okay, so I will correct that. Please have a look at the marking scheme. Pause this video, take your time, and compare your answers with this answer. I have noted down that they have rounded it off to 790. Mathematically, it should have been rounded off to the 790. Okay, so let me take that out and we will correct it. Okay, so let me bring the felt pen. Where's the felt pen? Here we go. So this should be 790. Okay, so this should be 790. Okay, so 785.7 mathematically, it should be rounded off to 790 into significant figures. So that was a little mistake. So let's go to the next part. The question number 4 is coming up. Okay, so let's go to the next part. Question number 4. He says in the figure 4.1, AB represents a converging lens, and object PQ is placed with the end Q on the principal axis ST of the lens, and the point F is a focal point, principal focus of the lens. Measure the focal length. Okay, so let me increase the size so you can see the diagram. So this is the principal focus. This is the optical center of the lens. If you want to measure the focal length, put a scale beside this line on the principal axis and measure the distance between the optical center and this principal focus, and that will be the focal length of this lens. So let me show you. I have done this on a paper. here we go. I have measured this length from optical center to this principal focus, and that is 5.1 centimeter. Approximately, my answer is 5.1 centimeter. Okay, so hopefully you understand. Okay, so the next part. He says, draw a line from P. Draw a line from P parallel to ST to meet the lens AB at the point C. Label C. So here I have to draw a line from here parallel to the ST, parallel to the principal axis, and when that line will touch this lens, I will name it, available it as C. So this is what they are asking for. So let me show you. I have done this. So here, this red line from P to C, this is parallel to the principal axis. When it touched the lens, I labeled it as C. This is what they are asking for. Hopefully you understand. Okay, the next part. Explain how you measure that this line is parallel to the ST. Okay. So if you want to measure that this line is, if you want to make sure that this PC is parallel to the ST, I will measure this distance. The distance of the P from the principal axis, perpendicular distance. If this distance and the distance of the C from the principal axis, the perpendicular distance, both these distances are equal, then this means that this is parallel to the principal axis. So let me show you my answer. Check the distance of the P from the principal axis. Check the distance of C from principal axis. If both distances are equal, PC is parallel to the principal axis. Okay, so here we go. Draw a straight line from F to C and extend this line until it meets the dotted line at the point R. Label R. So what they are talking about. Let me show you. This, they are talking about this. Join the F and the C. It will be a continuous line, and then I will prolong it behind. It will be a dotted line. I will continue until it crosses this line, which is coming from the P. So where that crosses it, I will label this point as R. So this is what they're talking about. Okay, then measure the angle theta between the line RC and the CP. So they are saying measure the line between the RC and the CP. So here I will put a protector. The center of the protector, the crosshair of the protector will be on the C. The zero of the protector will be here. And I will check how much is this angle. And I have already checked it. It's 24 degrees. It's 24 degrees. Hopefully you understand. And you will be able to do that. Very simple thing. Determine the length L in centimeters, where L is equals to 2.2 divided by sine theta. So I will just put the value of the theta here. So let me show you. Okay. So sine theta is 24. So I will write 2.2 divided by sine 24 equals to, that will be 5.4. So the length is 5.4 centimeter. So let's check. What's the next part? And that's the last part. F part. Theory suggests that L is equals to the distance CF. Measure CF and comment on the extent to which your results agree with this theory. Okay, we can measure the CF. Okay, let me show you. Okay, so I will measure the length of the CF. So put a scale here and measure this length CF. I have done that. Measure with the help of scale CF and then check it with the value of the L. And theory says that they will be equal to each other. CF is 5.4. When I measured it, it was 5.4 centimeters. So they agree with each other. So the L value is also 5.4 centimeters and the CF value is also 4 centimeters. So they agree with each other. They are matching with each other. So we are done with this question. And let's go back to the first. Okay, so my dear students, we are done with this paper, and here on your screen now you can see the marking scheme of the question number 4 is showing up. Pause the video, take your time, and you can read these answers. It's very important. Always remember, make it your habit whenever you do a question. We check the answers with the marking scheme. We have made a rule, and that's our rule. We say that we never attempt any question. We do not attempt any question whose marking scheme we don't have. Okay. If I will give you a worksheet, if I will give you a test, I will definitely have its marking scheme. I do not attempt any question whose marking scheme is not around. Because once you have done the question, then you compare your answers with the marking scheme, with the standard marking scheme issued by the University of Cambridge. So hopefully you have read this marking scheme. So we are done with this question, with this paper. So, my dear students, today we have done October-November 2017 Physics 5054 4-1 paper. This was paper 4, alternative to practical. And I have tried my best to explain the concepts of this paper. If you think that this video has helped you, if by this video you are able to understand that paper, you are able to attempt that paper, do like my video and share the link of this video onto your social media accounts, for example, Facebook, Instagram, Twitter, because that promotes my channel and that gives me energy, and that's a big appreciation for my work. So thank you very much. It's a pleasure teaching you all. Thank you very much. Have a good day. God bless you.